guys, we're going to go ahead and look over chapter 3, lesson 7 from our math book. So for problems 1 and 2, circle the best estimate and explain your estimation strategies to somebody at home. So when I think about estimating fractions, I think of whole numbers like 0, and we got half and 1. Then you have 1.5 and 2. So really when we estimate, we think about counting by halves or not counting by anything at all. But if I start with 0, then half, then add another half, a whole, and so forth. So really thinking about, is this fraction closer to 0, half, or a whole? So the sum of 3/4 is, and 18/19 is closest to what? So if I were to add 3/4 plus 18/19, what's my estimate? Well, I could say that 3/4, I could go either way. I could say 3/4 is close to half, or I could say it's close to 1, because it's right in the middle. So I'm going to say 3/4 is close to 1, and 18/19 is very close to 1 as well. Well, what is 1 plus 1? It's 2. If you went with 3/4 is close to half, that's fine too. That would have just changed that to half here, and then 18/19 would have stayed the same, which would have been close to 1 and a half. So estimation just really kind of helps us get an eyeball for the answer. Oh my gosh, I'm so silly. I didn't realize down here where it says circle the best estimate that I would just circle the 2. But if you said 1.5, that was okay too, even though it wasn't an answer to circle. So sometimes when you have that problem, then you just got to think about that. 2 and 3/4 minus, 2 and 3/8 minus 3/4. Okay. Well, here I have to think about 2. Well, that's a whole. But 3/8, that's really close to half, because half of 8 is 4. So I have 2.5. And based on what we just learned, the book is probably going to say that 3/4 is the same as 1. So, well, what's 1 minus 2? That's 1. Well, then I got to take away another half. So is my answer going to be greater or less than 2? It's going to be less than 2. In fact, I would probably say it's going to be close to 1.5. For problems 3 and 5, refer to the number line below. I look at this number line, it's section from 0 to 3. Here's a whole and another whole. I always like to mark my holes. And then, in my final whole 3. And then it counts by halves. Henry ran 1 5/8 miles in the morning and 9/10 miles in the afternoon. About how many miles did he run in all? Place an X on the number line to show your estimate. So 1 and 5/8. 5/8 is very close to half. So 1 and 5/8, and I'm going to do these squiggly lines. These squiggly equals, because it means about. 1 and 5/8 is about 1.5. Okay, so I have 1.5, which is where he starts here. I'm just going to put a little fake mark there. And then 9/10. 9/10 is extremely close to 1. It's about 1. So I'm going to go from 1.5 to 1 more. So here's half, and here's another 1. So here's that X. So he runs about 2.5 miles. Tina ran 2 7/8 miles. George ran 1 1/10 mile. About how many more miles did Tina run than George? Well, how many more? That tells me what? What does that tell us? It tells us we're going to subtract. So Tina runs 2 7/8. What is that close to? Well, 7/8, that's really close to 8/8, which is 1. So 7/8 is close to 3. And then we got George here, who ran 1 and 1/10. 1/10 is close to nothing, or 1. So this is just going to be equal to 1. So if I take 3 and I minus 1, I would get 2, place a star. So I need an X and a star. Explain how you estimated. I just went through that process. So first we find an estimate for two and 7/8, which is about 3, and an estimate for 1 and 1/8, which is about 1 and 1/10, I'm sorry. And then we subtract. 3 minus 1 equals 2. Ooh, volume. I have my volume formulas listed here. I either am going to do volume equals the area of the base times the height, or volume equals length times width times height. And what I love about volume is it uses multiplication. And with multiplication, we know that order does not matter. What is the volume of a box that is 14 inches long by 7 inches wide by 10 inches high? So here, I'm going to figure out what formula works best. Well, I have 3 dimensions, so I know that this third dimension here will work the best. So my number model would be 14 times 7. I'm going to go with that because at the end, if I multiply by 10, I know my tens trick. Equals V for volume. So let's go ahead with 14 times 7. And if you know how to do this, you can fast forward and make sure you just are checking your answer. Or if you really need help, make sure you're following along. 7 times 4, here's my 8. Regroup my 2. 7 times 1 is 1. Sorry, 7 times 1 is 7, plus 2 is 9. So that 14 times 7 is 98. Next, 98 times 10 I can do in my head, because 1 times 98 is 98. Then add on my 0. 980 inches cubed, or cubic inches. A floor-raised classroom has an area of 525 feet, and the ceiling is 15 feet high. What is the volume of, oh, I thought that was Ray, I'm sorry, Raj, of Raj's classroom? So I have to figure out the volume formula. Which one are we going to use? Well, this B here is area of the base, which we have at 525 feet. How tall is it? 12 feet. So I'm going to take 525 and multiply by 12 to get my volume, which will tell me how many cubic feet this classroom is. I'm going to go ahead and set up my multiplication problem. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10 again. Oh, I'm not liking this. I don't have enough room. So rather than cramming, I like to start over just to make sure I'm not rushing and that I'm saving my time. That looks kind of weird. So 525 times 12. Let's start over. 5 times 2, 10. 2 times 2 is 4, plus 1 is 5. 5 times 2 is 10. Now I'm going to multiply by this 10. It's not really 1, it's 10. So I need my placeholder 0. 1 times 5, 1 times 2, and 1 times 5. Add them up. Oops, lost my train of thought there. 6. So my answer is going to be 6,300. I always want to make sure that I go back and write it here. Now make sure that if you have something on the back of this assignment, you finish that as well.